My name is Mark, and I will be giving a brief intro to IQEngine for those who haven't heard of it, as well as a few demos and an update as far as what the project's been up to over this last year. So, to get started with, IQEngine, it's a browser-based app for managing your RF recordings, including sharing them, analyzing them in certain ways, processing them, and it's all in your browser. So it's extremely accessible. There's nothing to install as far as using it in the most basic way. And it's easy for me to share IQEngine with other people because I just point them to a website, which I'll show you in a second. It's entirely built on top of SIGMF. It started a few years ago, and the idea was to make the ultimate SIGMF tool and make it browser-based, mainly for accessibility. Now, IQEngine.org is a public instance of the tool. It's what we use to show it off, as well as use it to share recordings. And I guess other people use it to share their recordings with the world. And hopefully one day it'll also be used to share RF functions, I'll call it. It's really broad, any kind of RF functionality that you might run on a set of samples. You could show off and kind of demonstrate as a plugin to IQEngine. And not only, so IQEngine.org, it's kind of like the public instance of the tool, but there's a lot of functionality at IQEngine.org for you to analyze your own local recordings. So even if you have a bunch of local, like IQ files, you can use IQEngine.org if you don't want to set up everything yourself. And kind of like you'd open it in Spectrum. It's a spectrogram-based viewer. So let me dive into sort of the basics of what the tool is. Try to hit all the specifics I wanted to here. Okay, so IQEngine.org, first off, I wasn't sure what the Wi-Fi would be like. Let me zoom way in. This is IQEngine.org after you go past the landing page. And you can see the Wi-Fi AH from the talk this morning. From Sam's talk, and then the GRCon CTF recordings are all here. So if you're someone who's not into the CTF, but you're kind of curious, like you just want a quick glimpse at it, like these represent most of the challenges in the form of a signal recording, and some of them look kind of interesting here, right? So, and the idea with each one is this lists all the recordings in that like bucket, but you can click on one of them, and you're brought to a spectrogram-based viewer. And the way it works, well, I'm on the Wi-Fi one. Let me switch to my local instance. Okay, so I'm running IQEngine on my laptop as well. And this will be a lot faster. So you can click one of the recordings, and you're brought to a spectrogram-based interface. So on the right, we have a mini-map, kind of like in VS Code, where it's the whole recording. This is just a few FM signals that stay relatively static. And the way it works is it's only downloading the samples you're looking at. So if I jump into the middle of the recording, it's going to download those samples. It's indicated on the right. This little gray box shows you what's been cached in your browser. And then everything else is done client-side in your browser, like the FFTs. And if you add any filters, there's a lot of different options. That's all client-side, luckily. And okay, so I said it was built on top of SIGMF, but you haven't really seen anything too specific to SIGMF yet. Let me jump over to a recording that has some annotations, like this guy here. So annotations in SIGMF are used to draw a bounding box in time and frequency around anything of interest. So in this example, you know, there was some sort of classifier run on a portion of the signal, and they're using SIGMF annotations to represent the classification results. You can have as many as you want. They also show up on the mini-map as little white boxes. And then within IQEngine, you can actually add an annotation manually. Most people, you know, have tooling around that, but if you maybe, there was something here that was missed, so you could like label it missed, and then what happens is everything you see here, it's all based on SIGMF. So you have the SIGMF metadata, which is shown at the bottom at any given time, the raw metadata here. So this represents this is the metadata file. We have the sample rate, the author, which is Jacob in this case, you know, the hardware that was used to capture the signal. But then if we keep going down, we can get to the annotations. And there were already a bunch of annotations, but the one that I added, I guess it's at the bottom right here, is now added to the list of annotations. As you can imagine, you can download the metadata JSON. So that way, if you're collaborating with someone, the data might not be changing at all, but maybe you're, like, let's say you add a bunch of annotations, you can share the metadata only. You could even like use Git or whatnot to revision control the metadata. A lot of people will put the metadata in a database like MongoDB so that it's quick to query and search over your recordings. As far as the other kind of basics of IQEngine, you can add filters, change the color map, everything you'd expect. This Python snippet is pretty experimental, but you can run a little bit of Python on the signal before it gets generated into a spectrogram. And then lastly, let me show off plugins really quick. So if I go to the back to the FM recording here, the way plugins work, you select a region of time that you want to send to the plugin, so a region of the samples in the file. And you can even edit this on the mini-map if you want to send like the whole file. And then you scroll down to the plugins section, and everything you see here represents RF functionality that's running on the back end, not browser-based. So we support Python-based plugins, GNU Radio-based plugins. I'm going to run there's an FM signal detector that I threw together. It's like super simple. And the way it works is it sends the samples to the back end, which in this case is my laptop. And that one did not work great. But, well, there's multiple FM signals here. But let me do that synthetic signal. So this signal here has three examples, and I use this for my students a lot because it's like, it's kind of as straightforward as you can get. Back to plugins. So there's a detector plugin, very simple detection algorithm. And you can see it only processed the region of time that I sent. But it returns its results via a SIGMF annotation. And as you can imagine, the annotation's now in the metadata at the bottom. Now the last part, I'll show you GNU Radio. The GNU Radio-based plugins, they run exactly the same, but they're implemented under the hood as a Python flow graph. Okay, so that's the idea of the plugins. There's also time frequency IQ, and I'll get to the cyclostationary part at the end. Now, I'll mention the time frequency IQ right now, it's just Plotly, fairly straightforward. So I think as far as where IQEngine has to grow, a ton of work's been done to make this custom spectrogram screen that has all these different widgets on it. You can scroll down and it'll automatically fetch the next samples from the server or the cloud. But the time frequency IQ, it's really just sending whatever samples you're looking at over to Plotly, and then it's styled, but there's really not much else there. So I think having some custom plots there could be a nice next step. All right, back to the slide deck. Did I have it open? All right, so, actually really quickly, when you're in the recording list screen here, let me zoom out just briefly. You get kind of the gist of the recording, who was the author, what's the data type, how many samples, and then the ones that have annotations, you can click the little button above the annotations and it'll give you a pie chart showing the distribution of the labels of the annotations. So that can be pretty useful for RFML research and such. You also have a table of the annotations. I think the first 100 show up here. So it's a nice way to quickly skim through recordings. You can imagine if you did not use SIGMF, you just had a bunch of IQ files, maybe your metadata is in a database, in a CSV file. Doing this kind of quick skimming of a new data set is not as easy. And it also makes it a lot easier to share stuff with folks because they can quickly get a look. So no longer do you have to give someone an enormous zip file, like a 30 gigabyte zip file, and have them spend a whole day going through it all. You can share a data set. If you want to share a data set with somebody, you could do it much easier with this kind of tool. And okay, so now, I want to mention the Sam Millers and the CTFs recordings that were recently added. I will say the GNU Radio repo, as we're calling it, the first category, is sort of a dumping ground for everything. The other repos on IQEngine.org, So Daniel Estevez has a whole collection of satellite recordings. Airbus has a RFML data set. And I think these last three are all RFML data sets that were contributed by the company and universities here. So if you are at some organization or university and you're doing either RFML or really any RF work that has recordings, we're happy to add you on the side here if you have some interesting recordings to share with the world. Yep. Okay. Yeah. Is it 30? Okay. Next up is, yeah, I was gonna say, I was like, I'm only halfway. I think it's a 25-minute talk, but okay. So since last year, I mean, some of you, this may be very repetitive. Apologies for that. But since last GRCon, the biggest thing we added, and probably the most important for a lot of you, would be you no longer have to store your recordings in the cloud. You can now use what we call the backend data source, which is really just whatever backend server or computer is running the backend part of IQEngine. There's the backend, the front end, and then the plugin server. So as long as the backend can see the recordings locally, like a mounted NAS or whatnot, you can keep them there and then serve them. The other big thing is we now have SIGMF converters. So it's now this kind of central location for open source SIGMF converters. And I'll show them in a second. You can, within the client side, within the browser, you can do a frequency shift or a square function. The squaring is popular for like hackers to find offsets, center frequency offsets. So you can square the signal. And then the frequency shift, the way that works is you drag this line, and then the results are not immediately shown in the spectrogram. Instead, like the time version here will show the shifted. That's a bad example. We'll show the shifted version. So there was a massive overhaul to the browser page. It used to be that each of these categories on the left here, these kind of buckets of recordings, were like a separate, like you had to switch between pages. So Bernard helped a bunch with the UX design, and we now have this nice system where you can quickly switch between the different buckets. And then there's still the thumbnail and description for each one. The SatDump plugin was demonstrated at FOSDEM earlier this year. It's pretty simple. It only supports a couple pipelines, but it shows kind of the reason why you might want to show off RF functionality in a browser. So if you wanted to, if you were the maintainer of SatDump and you were trying to show it off to someone, and you were on like your phone or like a computer that didn't have it installed, you could go over to IQEngine, pick one of the recordings like of NOAA APT that you know works well, run it through the plugin, and then right now we're just kind of showing graphically the results, but it's a starting point. Now, like I mentioned, you can run your own instance of the tool. For most people, it's not necessary. In fact, I didn't show it yet, but if you go to IQEngine.org and you go to the local directory on the left, you can open a local directory on your computer. Anyway, let me use this one. I think it was already set. There we go. So this directory on my computer here had a few recordings in it. So it's pulling it locally. You can do this like right now with IQEngine.org. Everything's kept client-side. So like the thumbnail that just got generated, that was done client-side. If I go into one of these recordings, everything here is client-side. But I will mention if you run a plugin, that is going to send the samples to the server. So that would be the one situation where, if you had really sensitive data, you wouldn't be taking my word for it. But if you have somewhere in the middle, right, and you avoid the plugins, then yeah, everything's kept client-side. And in addition to the directory, you can open a pair of files, meaning a data file and a meta file. So data, meta, and then it just brings you to the spectrogram page for that file. And actually, while I'm here, let me quickly show off the frequency shift. So we have a tone. In this example, there's actually a weak tone as well that's hidden. But if I frequency shift over to the tone and then go to the time GUI, and then I got to zoom in a bunch. Zoom in. So you can see there's like still a slight offset, and then you can change the frequency offset down here on the bottom left manually. And if I make it exactly what it was, then the offset goes away, and you can see the DC signal. You can turn off the frequency shift, and then you're just going to get the high frequency tone. But okay, so my point is most of you don't need to run your own instance, but if you do, so if you're someone at an organization or a company or a school, and you want to share private recordings with the rest of your colleagues, it's very easy to run your own instance here. You can also use the server you're running it on as the place to store recordings, which was not true a year ago. Most of the work is filling out a single environment file to specify the source of your recordings and some other parameters, like you can skip the landing page, for example. Now, as far as running an instance locally, you can either use the latest published Docker image, and in which case, if you have Docker running, it's like one command after filling out the environment file. If you want to run from source, but through Docker still, there's a way to build and run, as you can imagine. And then what I tend to do for development is run from source without Docker, in which case you have to run the back end and the front end separately, and then you have to do all the pip and npm installs on your local machine. You also have to have GNU Radio running locally if you want GNU Radio plugins to work. So the Docker images are very useful for testing out stuff like the GNU Radio and sat-dump plugins. You don't have to care about what kind of environment you have configured. Now, either method you use here, you would open up the locally running instance with localhost and then whatever port was set, which is exactly what I have running up here since I wasn't sure about the Wi-Fi. And in VS Code, it's going to be tiny, but yeah, so I got it running here, and then I'll show you a couple quick examples of the converter later. All right, back to the slides. Now, the other kind of cool feature that was added, I don't know how many of you have ever messed with cyclostationary processing. It's kind of a niche area of RF DSP. But now there's a nice, easy way to get into it. So the idea is there's this spectral correlation function where one axis is your RF frequency, just like a waterfall, and then the other axis is known as the cyclic frequency. And cyclic frequencies are caused by like a symbol rate will determine the cyclic frequency. OFDM has some built in, especially because of the cyclic prefix. A lot of different waveforms have cyclic frequencies because of the nature. I'm not going to get into how exactly cyclostationary works. I will mention PySDR now has a chapter on it that starts you from scratch and builds up with a bunch of examples. There's even an interactive something just like on IQEngine, interactive SCF. Except on the PySDR, you can change the signal like symbol rate and stuff without having to make a new recording. But on IQEngine side, you can, so I made a example signal here. It's simple BPSK, rectangular, pulse-shaped with 20 samples per symbol. So it looks like you'd expect, a little bit of noise. It's a very short recording, so it doesn't fill out the spectrogram. But if I go over to the cyclostationary tab, right now you can choose your alpha start and stop, and that's the cyclic frequency. It's actually normalized from 0 to 1. And the way to think about this would be, it's like the inverse of your samples per symbol. So if I've got 20 samples per symbol, I would expect some a cyclic spike at 0.05 alpha, right? So the PySDR chapter goes a little deeper into how that works. And then you choose the resolution and calculate. And this is actually running in JavaScript client side. So it's the first client side kind of JavaScript SCF that I've ever seen in the wild that I put together. And here we have the SCF of a rectangular BPSK signal. There's a huge spike at the frequency offset. In fact, I didn't point it out, but there was I think a 200 kilohertz offset. And by the way, you can use like the time cursor if you want to measure something here. So we can see there's 200 kilohertz, and that will show up in the SCF. So We can see the spike at 200 kilohertz, and then the y-axis is alpha. It's labeled at the bottom here. It's normalized alpha in normalized hertz. And we can see the spike at 0.05, like you'd expect for a 20 samples per symbol signal. Now, rectangular BPSK also kind of has harmonics in the cyclic domain, so you can barely see it, but right here, it actually keeps on going, but the noise is hiding the rest. Are the harmonics. If you have a pulse-shaped BPSK, you're not going to see all these harmonics. And there's a link to the PySDR chapter if you want to learn how cyclostationary processing works. Check out that link. Somewhere around the middle of the chapter is the interactive kind of SIGGEN with the SCF. But we start from scratch. There's a little bit of math, but a lot less than every other textbook. There's a lot of Python examples. There's full Python implementations for everything, unlike some other resources out there. All right, last big demo. So Daniel Estevez, as many of you know, created Maya SDR, which is a special Pluto firmware image, and it gives you a real-time waterfall. It does FFTs on the Pluto's FPGA. It provides a web interface on the Pluto's ARM core. So nothing's running on your machine. In fact, if you had a Pluto Plus, you could have it networked, like connected to a switch. And it exposes this awesome spec-in that I'll show you in a second here. But what Danny did was added IQEngine integration. So he already had a way to take a recording. It stores it in the Pluto's RAM. There's 500 megabytes of RAM on the Pluto. 400 of that is free. So he's filling all that up with the IQ recording. Now you can download the recording to your computer through the web interface, or you can use IQEngine to view it without having to download it. So, and I want to point out how easy it is to install, to get Maya running. In fact, I put the steps here. You pretty much download the firmware zip. You copy the Pluto firmware onto the storage device that pops up when you plug in your Pluto. And there are a couple environment things to set when you SSH in. But once it's all set up, and you only have to do this once, you simply go to the Pluto's IP address in a browser. So I think it's 192.168.2.1, port 8000. And this is my SDR. So it's a real-time, just a waterfall for now. And it's doing FFTs on every sample, but then it's averaging and decimating. You can also change it to peak detect. So let me go over to maybe the 915 band, and there's something fun there. So let me, okay, now if we want to record the signal, we click record here, and it pretty much records until it fills up the 400 megabytes. Now you can download the recording. I'll click that, and it just downloads the file like it's any web download. Or you can click the view in IQEngine, and it's actually running IQEngine on the Pluto, and it opens up the Pluto's version of IQEngine, which is just, I don't know how it's able to run so much on the single core. So record, and then stop. You can stop the recording early. IQEngine. All right, so so this is IQEngine running on the Pluto, not using IQEngine.org. It's not using the local one that I was running. And this is the raw recording. So what it's doing is, it's grabbing the samples you want to look at, just like the normal version does. And you have pretty much every feature from the spectrogram page. So this was an awesome integration done by Danny, and I'm really glad to show it off here. All right, back to the slides. So the last little bit, we now have a place for SIGMF converters. So if you want to create your own and share it with the world, I think this is probably the only real spot. I won't bother running through an example, but right now we only support WAV files and then Vita49, but it's really only the Diffie variant. As a lot of you know, Vita49 is a huge family, and I can't imagine writing a converter that would work for every Vita49, like PCAP. But if it's a Diffie PCAP, it should work, at least off the certain digitizers out there that use Diffie. So big thanks to Simon and Roman from Airbus. They were the ones who did most of this work. And you can check it out for yourself. So the way it works is you can go to IQEngine.org, And then there's a little miscellaneous tools. In the top right, there should be a miscellaneous tools button. There's I recommend checking all of these out, but the converter has a web interface. So if you have a WAV file, like downloaded off SIG-ID Wiki, you can upload the WAV file, and then it'll give you back the SIGMF version. Now, if you don't want to have your data uploaded to the cloud or wherever, you can run the same exact converter locally. So there's even instructions here for how to run it locally. But you'll have to clone, oh, no, that's a dead link. You'll have to clone the repo, and I've got it open here. So you essentially clone the repo, and then you run the top level. Each converter has its own top level script where you can feed it the WAV file or the Diffie file, and then it'll convert it and output the results in the same directory. So I think this was in temp. There should be some SIGMF recordings now somewhere here. Yeah, there they are. So yeah, if you're into SIGMF and want to kind of contribute more recordings, let me know, and I can kind of show you where to commit them to. All right. Lastly, so there's a Discord channel as far as the community, in addition to the GitHub issues and PRs. We have Google Analytics running on IQEngine.org. It's only really checking like that someone went to the site. It's not looking at the specifics, but I've got some screenshots here of those statistics. Quite a few unique users every month. And then as far as how to help, so if you're interested in contributing anything like major, definitely email info@iqengine.org to get some conversations started. Now, I already mentioned the whole like time and frequency tabs, I think have a lot of potential to be beefed up a bit. So I can imagine something similar to Universal Radio Hacker's interpretation tab, if you've ever used that, where you can pick different modulation schemes and such. I think it'd be really cool to have a web version of that. It would allow people who want to do the CTF to not even have to install anything. They might be on like some work computer with just Windows and not want to mess with that, and they could go a little deeper with the CTF. By the way, some of the CTF challenges are solvable to this, like right now, entirely in IQEngine. Just a couple of them. And now, alternative to actually developing something custom, if there's a purely web or WebAssembly signal processing framework out there that like requires no backend, it would be cool to somehow integrate that so that it could be more of a dependency, and you could do the actual DSP from the browser and work back and forth. If anyone's interested in helping to organize the RF recordings, we're still looking for someone to be like the official curator. That's why every time I do these talks, the list of signals looks roughly the same. There's actually a lot that's been added, but they've all been like, added to different directories, like back to IQEngine.org, if it loads. Most of these were not here last year, actually, but a lot of it's like buried in, like in space. You can see all of these different categories now. So yeah, if you're interested, we could definitely use someone to focus on organization. And with that, I'll take questions, and you can show your support by starring our GitHub. Thank you.